Hello friends, welcome to the Basics of Geography series. And this is our IS Conclave Institute, which provide you free as well as premium videos on various subjects. And for that, please subscribe our YouTube channel so that you can get an updated information and videos. And this is our Geography Incubation series for civil services examination, and especially to strengthen your basics of on geography, and especially for those students who lack their basics of geography, their fundamental understanding on the geography. So in this session, we will help you to strengthen your basics on geography. So in this session, we have covered already the minerals and metals. What are minerals? What are the various different properties of the minerals, and how do minerals form? So for this video, you can refer our YouTube videos. So now in this session, we will cover magma and igneous rock. In this session also, we have covered the what is magma and how does magma different from the lava. What are the major component of the magma also we have covered. But in this session, we will cover process of the crystallizations. So to better understand how magma convert into the crystalline rock, to better understand this, we have to simply understand the process, the reverse engineering. So we will understand it through reverse engineering, like how a solid rock melt, how a solid rock melt. So we will understand this through. So simply understand ki if melting convert a solid consisting of the tight uniformly packed ions into a liquid composed of unordered ions moving randomly about. How this will happen? Let's understand. Because we know what is crystal. So we have to first understand what is crystal. So crystals are orderly. Crystals are orderly and uniformly packaging of the ions. So this is crystal. So if we given a hit, if we increase the temperature of the minerals or rock, so what will happen? So whenever there is a crystal formation, it is solid, or ions have a very confining moment, very restricted moment. So whenever temperature increase, so what will happen? Ions will have movements. So जैसे जैसे टेम्परेचर इंक्रीज होगा, देन these ions will starting colliding with each other. So whenever they starting colliding, so heat will generate, and this heat generate will give enough space to the ions. So at one point, whenever the temperature will increase continuously, so this will increase, this will attain a certain level of temperature. This is called threshold temperature. So at threshold temperature, bond will break, ions will break apart. So what will happen? The ions will have an unordered ions moving randomly about. So they will have a very random movement. But now we have to understand the process of crystalline. Now we will understand better in very simple process, the crystallization, cooling reverse of the events of the melting. Okay, so as the temperature of the liquid drops, whenever the temperature of the liquid drops, so ions pack more closely together, because we know that if the temperature is high, ions have a very random and unordered movement. But whenever the temperature is starting declining, so they have a very confining and restricted movement. So at one particular point of time, at one particular temperature, they will starting bonding with each other. They will starting bonding with each other. So you will understand this through when magma body cools, the silicon and oxygen atom link together, and they will form an oxygen silicon oxygen tetrahedron. But after cooling process, now because this cooling process is a continuous process, so whenever the cooling happens, cooling occurs, they will starting together bonding. So these silicon oxygen tetrahedron are starting bonding with each other, or even other ions also are starting bonding with them. What we call them? We call them embryonic crystal nuclei, because from embryonic stem cell the whole body is developed, and this is like from embryonic crystal nuclei, whole crystallization process is complete, whole crystal form. So now slowly each nucleus grow as ions lose their mobility and join the crystalline network. So whenever the temperature starting declining, so each and every ions starting losing their mobility and joining the crystalline structures. Eventually all the melt is transformed into solid mass of interlocking silicate minerals that we call them igneous rock. Now we have to understand the what is interlocking silicate. So here we can understand the interlocking. You have understand if you have a very very general example of the construction. Okay, in the building, the bricks have a very interlocking pattern. Why? Because to provide the strength to the building. Okay, so this is how potassium feldspar, amphibole, quartz, and feldspar, they have a very interlocking, because magma have a composition of the different minerals. So when they solidify and cool, so they form an interlocking structure. So this shows an interlocking. And if you like our videos, please share and subscribe our YouTube channel. And thank you guys.